A. McLaughlin. Um, Starting with Melanie. Melanie McCaleb, MS, CPESC, is the owner and operator of NTU Incorporated out of Raleigh, North Carolina. She received her Master's of Science in Soil Science from NC State University under the supervision of Dr. Rich McLaughlin. She spent 7 years following her graduation working in soil science department doing research and discovery on numerous NCDOT projects using new technology to help reduce erosion and sedimentation on construction projects. She left the university in 2012 to start her company. NTU is primarily a consulting firm to the erosion, sediment, and turbidity control industry, lending expertise and knowledge to national home builders and DOTs in our region. Thanks again, Melanie, for taking time out of your busy schedule to help us with this webinar today. Next, we have Dr. Richard A. McLaughlin, is in the Department of Crop and Soil Sciences at NC North Carolina State University, where he has 28 years of experience in research and education on all aspects of erosion, sediment, and turbidity control on construction sites. His research has led to the adoption of numerous innovations which have been adopted in many states to increase sediment capture efficiency. He served on the International Erosion Control Association Southeast Chapter Board for many years and continues on the IECA Standards and Practices Committee. He is also serving on the Sedimentation Control Commission for the state of North Carolina. He is the recipient of the 2010 Training Program Award and the 2020 Environmental Excellence Award from the International Erosion Control Association, the 2010 Applied Research Award from the Soil Science Society of America, and the 2020 Achievement Award from the Soil Science Society of North Carolina. Thank you again, Dr. Richard, for helping us out today. And without further ado, I will pass the ball over to Dr. Richard, and the next voice you'll be here.
All right. Well, thank you, Michelle, for that introduction, and welcome. I'm glad to see everybody out there. I think I see a lot of pajamas. That's okay. Whatever mode you want to be in to learn this morning, that's fine. So Melanie invited me to kind of start this off and kind of lay the background for the work that she's doing right now with NTU. And so we're going to start with that, and then we're going to move into her examples of how all these principles can be applied in real life. All right. So let's start with the picture you see in the background here. You've got an excellent example of a sediment basin with baffles and a nice protected inlet, etc. But you also will notice that we've got a lot of turbid water just sitting there. And I assume that's why most of us are here, to learn about how we can make that water be somewhat clearer and improve the quality of the water that leaves our site. So there's a couple of options we have for that, and that is to either filter it, which is a great idea, except that there's too much sediment in this water generally on construction sites, so a filter will clog very quickly. We could infiltrate all the water, and that would be great if we happen to have the right situation with permeable soils and maybe deep groundwater, but that's not going to happen in most cases in North Carolina. And so the third choice is what we're going to talk about today, and that's chemically assisted settling, which is very effective and very inexpensive if it's done correctly. So here's really the basic physical principles of why we have to do this chemical assistance. Our particles range in size from sand to clay in most soils. And when you get down to those clay particles, you can see the time to settle 1 meter, which is about 3 feet, the depth of most of our sediment basins. We're talking days, weeks, months even, to get those particles to settle, and that's under ideal conditions without storms, etc. So that's just not going to happen, and that's why in most cases our water ends up pretty turbid, even when we have excellent practices in the watershed. So speaking of excellent practices, let's talk about that. We need to make sure that In addition to the chemical treatments that we'll be talking about, we are pulling out all the stops to reduce erosion and control sediment up on the watershed. So, for example, areas that are not being worked should be covered up. If they're not going to be worked for a while, there should be some vegetation there. Ditches should be lined. We found that the ditches themselves, water conveyances, if they're bare, they may actually produce most of the sediment that you have in your basin. And so having good linings and check dams will prevent that from being a major source. So what we're trying to do is keep the sediment under control, except in the areas that we have to have active working. So one of the ways we can control the sediment, and most of you are familiar with these basins, is to put in a baffled skimmer basin. And on the left, you see an example of a diagram from the Standards and Practices Committee with the International Erosion Control Association. And that's sort of a mixture of research that we've done to show how you can be effective with that design. And then on the right, this is a standard DOT basin, very similar to what you see on the left, with porous baffles and protected inlets. So we're bringing the water in the pipe. So we don't have erosion on the sides. We've also got grass and matting, and then a protected dam and a skimmer. Those will all really help in retaining sediment. But again, we're not going to be able to retain the turbidity or the fine suspended sediment, even with these excellent practices. So for chemical assistance, we can go a couple of ways. One is using coagulants, and some good examples are alum and gypsum. There are a lot of iron-based compounds that are used out there in the water treatment business, not so much in turbidity control for construction sites. And these are okay, but they need to be applied in very large doses in order to be effective. And in fact, they may actually create low pH, and they may create excessive aluminum above state standards to dose enough to get the actual treatment we want. So we moved away from that whole class very quickly because it's very difficult to get the amount of material out into the basin. And we moved instead into flocculants. And the main two that we use on construction sites are polyacrylamide and chitosan, and I'll talk about those in a minute. And they're very effective at very low doses. So, for example, a pound of polyacrylamide can treat 120,000 gallons. So you don't need much. 1 or 2 parts per million usually will do the trick. So just kind of a funny example here, you see an early experiment we did with coagulants. On the right, you can see the pictures. It was a dispenser that was built by a senior design student. And what we found is it was an excellent design, but the gypsum would turn into a solid block when it got humid outside. So we had to toss that idea. It was fun while it lasted. Okay, so what else do we have? We've got different types of products like the effervescent tablets. Melanie uses a lot of those. We've got powder materials. That's the basic form that polyacrylamide comes in, and it's actually the cheapest form if you're going to use large volumes. You can have these socks that are filled with powder. Those are chitosan mostly, and there are some other chemicals that are used in those socks. And then finally, we have solid blocks, and many of you are maybe familiar with these. That's a proprietary product right there, but there's a number of them out there. So these are different ways that we can dose the water to get this flocculation, to get the polyacrylamide or the chitosan or other products up in the water column and start to dissolve and cause a flocculation. Just a little bit of chemistry here. So we have anionic polyacrylamide, and that's mostly what we use. There are some neutral or non-charged forms that also can be effective. But at the bottom, you see the cationic or positively charged polyacrylamide. And generally, we don't use that because if it accidentally is spilled in clean water, it can be toxic. The other two forms are not toxic at all. Now, if it's applied to muddy water, the suspended particles will neutralize that and it won't be toxic. But still, in most cases, we don't tend to use that. Chitosan is a product that's used in a lot of cases. I've seen it a lot out west in the United States. It's derived from chitin, as you can see in the diagram. Um, and because it is cationic, it can be acutely toxic. But again, if it's applied to muddy water, which is generally where we're putting these products, that will neutralize it. And they actually have a test you can use with some of the products that shows whether there's any excessive chitosan in the water column. So in all cases, when you're going to use a flocculant, you're going to want to do a jar test, which you can see here. Essentially, you put some of your soil or your muddy water into a jar, you put a product into it, and you shake it. And if you get flocculation, which you see here on the right, then you've got a product that works. If it stays cloudy, then that product is not going to work and you have to select something else. And that's really critical. You have to make sure you do this test or somebody does it for you so that the product you're using will actually work on your site. We're mostly going to talk about passive dosing today. That's where we allow gravity to flow or move the water, and we put the product where the water is flowing. One of the situations that works really well is to put it on check dams. And we recommend using check dams made of a natural fiber because they have a lot of surface area and this powder will stick to it very nicely, but still dissolve. So what we recommend is you apply some to the check dam and then some to the blanket on either side of the check dam. And the reason for that is that when water is flowing at a low rate, it may not overtop the check dam. It may go through it, and then it wouldn't get dosed if you only had the polyacrylamide or other product on the top. So put a little on the blanket and a little on the top. And the amounts I'm showing here, this half cup total that you put out, that's just something we came up with. I can't say that that was scientifically derived, but it seems to be a good amount and works pretty well in a lot of different cases. So you can see another example of a wattle. This one looks like it's a straw wattle and Excelsior blanket. So we're putting it on the wattle and on the blanket. So here's good examples of in the field applications. And on the upper right, you can see that this is a case where they had enough velocity they wanted to use a rock check dam. And that's fine. If you want to put flocculants out, instead of putting it on the rock, we would recommend that you put a blanket on the rocks and apply it to the blanket. That way you have that surface area to expose a lot of the water to the flocculant. And it doesn't take a lot of work to do that type of thing. Lower right, you can see a coconut fiber or coir wattle, heavy duty wattle. And notice how clear the water is. And that only happens if it's been flocculated. You're not going to see clear water otherwise. So I'm not going to go over all our experiments. I should have mentioned in the beginning, Melanie and I used to do this type of seminar, but it would take all day. So we're packing in a lot of information from our all-day workshop that we used to do. So here's an example of an experiment we did where we wanted to just see what the best application method was, whether we put it on the blanket, put it on the wattle, put it on both. And the bottom line here, you don't need to spend a lot of time looking at this, but the open bars, the clear bars, are where we didn't use PAM. And the solid bars are where we did use PAM. And it didn't really matter where we put it. We got pretty good treatment, reductions of 70, 80% in turbidity. So that shows you that you just need to get it out there and get the water running through the treatment zone. More examples of tests we've done, and you can see on the right how much turbidity reduction we had. And generally we're getting 70% or even 80, 90%, depending on how we put it out and what kind of turbidity levels we have. So higher turbidity levels generally will have a greater reduction, believe it or not. Here's an example of the solid block that we used to play around with. We don't do much with it anymore. But one of the things we found was it tends to dry out if you put it in a ditch and just let it be open to the elements. So instead, we would suggest that you cover it up in some way. In this case, we were putting it in a pipe and put the pipe on the check dam. You can also drop it into storm drains. You can put it um, in pipes that you have on a site, such as slope drains. That's a great place. Just cut holes and put the blocks in there. You could put the other solid form, the effervescent tabs in there, or you could even put the powder in there if you put something for it to stick to, like a blanket. So lots of options. Wherever water is moving, we can do a treatment. So inlets, you put it down in the hopefully you've got a basin that this is draining to, and that's another critical aspect. We have to drain treated water to someplace where the water will pool and the sediment and the flocks will settle. So you never do a treatment before it leaves your site. You want to treat on the site, settle it, and then send the clear water off. So here's the storm drain system that's already in. The log on the left is pretty much covered up, and on the right you can see it's not, and that shows you that you need to place it carefully so that it doesn't get covered up with sediment. Otherwise it won't dispense any product. Slope drains as part of your basin system. Here's an example of a tiered basin with two cells, and as you're moving from one cell to the other, you can put in your product inside the pipe, as you see there, and get a pretty good treatment there. This is an excellent, if you have the slope, this is an excellent treatment system. Here's an example of a really large tiered system. Very steep slope, hard to tell from here, but very steep slope, but lots of opportunity to do treatments before discharge here. So one of the questions people have is, here we are talking about adding a chemical to water that eventually is going to be discharged into streams and rivers. And so we want to make sure that that chemical is not going to cause any problems when it gets out in the environment. So some things we already know, it's very non-toxic. The anionic form especially is very non-toxic. Chronic tests, that is exposure to the chemical for a period of time, weeks or so, that tends to show also very low toxicity, so that's not really an issue. High doses on smaller species like Daphnia and Daphnia, which I'll show you in a minute, shows a little bit of sensitivity, but still not even close to where we dose. So we feel pretty confident that these products are not very toxic. So basic principle of toxicity is that everything is a poison. It's the dose that makes the poison, and that's something to always remember. That Paracelsus said this in 1580 or something like that, and that's the basic principles of toxicology. And so, some examples of water you can actually drown in water if you drink too much, and snake venom is sometimes used for wrinkles. So, all right. So here's our test animal that the state uses and North Carolina uses quite a bit, Daphnia, and they expose them to chemicals at different concentrations, and from that they can come up with an idea of how much is allowable in state waters that will not have a negative impact on aquatic organisms. And so we've done some of these tests with these different products, and you can see here this is the acute toxicity. So this is what actually is going to kill the Daphnia, and the cationic, as I said, in clean water is toxic. So that is shown here very clearly, that it didn't take very much to kill the Daphnias, but you see the anionic form is very non-toxic, even at doses way above where we would typically want to have turbidity control. So some examples out there, again, these are numbers that people have generated with other types of anionic, mostly products. The one that's low, the 14, I think that's an emulsion, and emulsified products, which you can use, say, in a hydroseeder, tend to be a little bit more toxic. So it's emulsifying agents that are doing that. We did do a very large test on campus looking at freshwater mussels, different species, different life stages, and the bottom line is the doses required to get any response were only showed a response in some of the species. And you can see 1,000 parts per million did not affect the animals in most cases. And that's, again, that's 1,000 times higher than we would normally dose. So we think it's a fairly safe margin in doing our treatments. There is some concern about acrylamide. There is a little free acrylamide in the product for polyacrylamide. And you don't need to read all this, but the bottom line is you'd have to drink a lot of water with a little bit of acrylamide in there just at the dose where there's no expected effect. You'd have to drink 28 liters a day to get to the no effect level, and that is probably toxic amounts of water. Um, fish are not affected by this. It's very non-toxic to most organisms. And it quickly degrades in the environment. So acrylamide in the very small amounts that you find in polyacrylamide tends to disappear very quickly. It's sort of candy to microorganisms. They degrade it very quickly. Well, what about the other side of the coin? And that is turbidity itself toxic? And this is an excellent example of how toxic it can be. If you look at how long at the bottom, the time of exposure and how much turbidity there is, then you can see that we've got lots of effects at fairly low amounts of turbidity. And this is a summary of studies that were done all across the world. So we know turbidity is toxic, and that's why we want to get that out of the water column. And kind of to bring it home, this is a lot of people like to fish for bass. This is an example of fairly low amounts of turbidity. We're talking 70 at the highest, which is sort of like weak tea. And even that had a very negative effect on bass ability to feed. So we really want to get the turbidity out of the water. So conclusions, we know that we're not going to see much toxicity with these products. We've done a lot of testing on that, but the turbidity itself and the suspended solids, they are toxic. So we really want to work to get that out of the water. The doses we use are 1 to 5 parts per million, and those are far below levels where you might see any kind of toxicity. And I think in my estimation that treating the water with flocculants is actually going to reduce the toxicity of the water rather than not doing any treatment. And I just want to acknowledge that a lot of people did a lot of work to get all this information together. I didn't do it all by myself. So with that, we're going to move on to Melanie. If I can get my cursor to move. There we go. Melanie is going to be
everybody.
the presenter here. So take it away with all your great examples.
Well, let's see. I got to figure out how this works again. Okay. So I am the presenter. Let's see.
Share at the bottom.
Yeah. I'm hoping. Oh, there we go. Can you see it?
There we go.
Okay. Good thing we practiced that. Thanks again for having us on this morning, Michelle. Rich, fine job with all of your solid information. I saw some good questions popping up from a few of you, so hopefully I can go through some of this fun real life information and cover some of those questions that were asked. So I'm gonna jump right into it. Rich kind of gave you all the background, how to use it, kind of where to use it. And then the question is, does it work? And how do we make it work? And how do we make it work better? So the first cluster of information I'm going to share with you is it's ongoing, and it's a very large residential and commercial site. A lot of exposed ground, a lot of sediment basins. And so we're trying different approaches, treating different areas. And this first picture shows a sediment basin that was not treated. So ideally, all of them could be treated. This one we chose not to treat more because of one, we kind of needed a control, if you will, and in an ongoing environment like this, it's really hard to have a statistically valid control. But this was going to be our control. And because the basin needed cleaned out, And so treating it would not probably have been very beneficial. The outcome would not have been that great. So this one was left alone. Okay. Then we had two basins. They were counted as two basins, but basically it was a large basin split in half with kind of a forebay area running into another sediment basin, but the forebay area was treated as a regular basin and it had baffles and a skimmer that drained into the second portion of the basin. So this was set up, and we did treat both of the basins, A and B. And so kind of jumping right into what we found. So basin A, so this was after we had treated the basins. Basin A, after a 1.5-inch rain event, we were getting turbidity values of 104 on the outfall and about 87 coming out of the outfall of basin B. So that would have been the second one. So clearly we were getting some significant treatment. And it was very exciting to see. Initially, the first samples that were coming out of there pre-treatment were over 3,000 NTU. So very high. With a little bit of polyacrylamide added, we were getting turbidity values knocked down significantly. And again, this was after an 1.5-inch rain event using the effervescent tablets. I believe in the next slide, we're going to be able to see, well, what we were doing is treating within the slope drains that were entering the basin. So it wasn't even a whole part of the watershed. We weren't treating in the diversion ditches. We were finding that those diversion ditches were often getting either removed or torn up, or and this was on a daily basis. So we were trying to go to an area where the treatment was basically treating all of the water that was coming into the basin on a consistent basis. And so treating within those slope drains that were entering the basin, we were getting all the water from the watershed. As long as it was entering those slope drains, they were being treated. And clearly that was happening with this basin. So these were two other basins, and they were side by side in the watershed. So it was kind of very interesting, the results that you'll see here. So side by side basins, same designs. So baffles, skimmers, spillways, slope drains draining into them. They were stabilized around the perimeters of the basin itself, and but different watersheds. So sediment basin 1 on the left had a watershed draining to it, and sediment basin 2 had a separate watershed draining to it. Initial pre-PAM samples, again, those turbidity values are significant, greater than 3,000. I say greater than 3,000 because that's as high as the turbidity meter that I use will go. So if it comes up error or invalid or cannot read basically on the turbidity meter, I know it's over 3,000. How far over 3,000, I don't know. It's beyond that. So these are the two basins in this particular grab that we're going to be looking at. On the left-hand side, the sediment basin 1, and the picture above it kind of shows the consistent destabilization of that watershed, of those diversions, because of grading activity daily. And so a lot of disturbance in there. On the right-hand side, that sediment basin 2, it wasn't nearly as active in grading and heavy machinery traffic. So we had really good stabilization actually in the watershed itself, in the diversion ditch, minus that scraggly looking wattle that got removed. But significant stabilization as compared to the basin that was right next to it with a different drainage. And so what did we find? By treating just those slope drains, and I use the effervescent tablets a lot. They're very easy to use in the slope drains for me. And so this is what I used on these basins were the effervescent tablets in the slope drains. And so the basin on the left, or the picture on the left, was from sediment basin 1. And we had on average, in this particular sample, it was 185 NTUs. And both of these bottles were samples taken right around the skimmer itself within the basin. The image on the left, 36 NTU coming out of that sediment basin 2, which was the basin to the right of basin 1. And it's kind of neat to see in the bottoms of those bottles that there's evidence of flocculation. So we knew that there was treatment going on. And while the basin on the left had a higher value overall, again, because of that disturbed watershed, the inability to get some stabilization in those diversion ditches because of the traffic moving in and out of there. But even though the basin on the left was higher at 185, it's still a far cry from the pre-PAM sample that was taken over 3,000 NTU. So while there was a difference, the overall outcome for both is significant. And here's another image. So in order to measure those samples, just put them into the glass vials that go into the actual turbidity meter. And you can really kind of see the difference there. Rich was saying earlier in the presentation, 70, 80 NTU is kind of like a weak tea. So this is a little stronger tea at 185, but the 36, you can clearly see that there's not a lot of sediment in that water itself. And that was within the basin. So always consider that once the water is discharging from the basin itself, that you're going to have continued treatment or continued settling of sediment. Once it comes out of the skimmer pipe, usually there's a rock swale or a dissipator pad of some sort where more sediment can settle out before it's going out the outfall. Sometimes there's silt fence outlets or whatever other type of outlet that would be at the perimeter of the basin. Again, more settling, and with settling, cleaner water. So eventually, by the time the water leaves the basin, leaves the job, it would be even cleaner than that. This was another sediment basin. And again, these are still ongoing, trying to collect samples as often as possible, more for presentations and whatnot, but not a requirement on jobs. This basin, great stabilization. You can see that the entire basin was lined with an Excelsior blanket. The spillway here in the foreground was lined with a permanent reinforcement mat, a proprietary material of sorts. And then baffles were installed. There is a skimmer for a dewatering device. Slope drains were used to collect the water to get it into the basin. Stabilized diversions. The diversions were lined with Excelsior, and wattles were used for the check dams throughout the conveyances that were entering the basin. Very well designed. So decided to treat within the slope drains. Again, these watersheds are extremely active, disturbed often. And so in order to make sure that the water that was entering the basin was all being treated, it was just easier to treat within the slope drains entering the basin. So you can see two different types of applications for getting the effervescent tablets into the slope drains. Highly scientific there on the right-hand side with my suet cage that I find incredibly easy for those tablets. They fit perfectly in there. And there's a little hook at the end of the chain, and it just fits right on the lip of the slope drain. And when it's empty, you'll know, and then you can reapply. Oh, there's another slip drain. This one was not in this basin, but I like this picture. The slip drain was coming into the basin, and material was thrown onto the dissipator pad at the bottom of the slope drain for more application as the water came through the slope drain and hit that dissipator pad with the Excelsior blanket. Rich was talking about adding some sort of fibrous material to the rock if you're going to apply onto the rock for the surface area. So there was granular material added to that dissipator pad. And as the water came through that slope drain within the basin, it was coming into contact with more polyacrylamide. So those were, I was treating within the slope drains. So the tablets dissolved. If you look, follow that top arrow, it shows you again that highly scientific suet cage that I use, and there is just a little remnants of some tablets in there, but the majority of them have been dissolved. And there is evidence of flocculation within the corrugations of that pipe. So you know that treatment is and was undergoing, which I think it's pretty exciting just to see it right there. So that big basin, even though the watershed was continuously disturbed and vegetation was continuously disrupted and a lot of energy and activity was happening within that watershed, treatment was certainly happening within the basin. The image on the left shows the outflow of the basin at this particular storm event, 20.2 NTU, and within the basin it was 115.3. So overall, great application, great treatment, and very pleased to see the success for this one. Again, though, if I can go back, there was a lot of variables that went in to help with not just the use of polyacrylamide. I think that's one of the caveats with polyacrylamide. It certainly is not going to work alone. It can't work if there's an overload or abundance of sediment. Rich showed you that the placement of the polyacrylamide logs in the storm drains, and if there's too much mud or too much sediment, they get covered and don't work. It's kind of the same premise with all of polyacrylamide. If there's too much sediment, too much work, it can only do so much. So when you have sediment basins designed in this capacity with stabilization and baffles and slope drains and skimmer pipes and stabilized diversions, and then polyacrylamide there to really polish up the water instead of having to deal with overloads of sediment, you have great results. Okay, moving to a completely different site, and this one was actually one of my favorite jobs that I was brought into. One, because it was a small site, and two, because all of the water drained to one sediment basin. I've not had that happen again, but it's very easy to control an entire site when it all comes to one central location. So the first sample on the left, over 3,000 NTU again, and that was before polyacrylamide was added. The middle image, or number 2, was post-PAM application after 0.6 of an inch rain event, and the sample was taken near the skimmer head in the basin. Number 3 was also post-PAM application, 0.6, same rain event, and it was taken in the basin at the first baffle. So closest to the pipe that was coming into the basin, that was number 3. The second one was closest to the skimmer head, and then the one was pre-PAM. I did not get a sample from the outfall at this point. Here you can see this is the sediment basin where all of the water is coming to, and there is clear water in it. It worked tremendously well. How did we treat? We did a couple of applications, or different types of applications. One, in that we had a lot of drop inlets or yard inlets or curb inlet protection, or curb inlets along this one main street, one large watershed that was draining to the one sediment basin. So we decided to add some polyacrylamide to the yard inlet protections, added some Excelsior fabric around that stone to again have more surface area for the granular polyacrylamide to be applied. So you can see on the right hand side the material where we use the granular PAM to treat the water that was coming into those areas. And then we used the effervescent tablets in the storm pipe that was coming into the sediment basin. I basically, just because I didn't have a place to hook up the tablets in their suet cages, I used some wattles that were stuffed with large wood chips, and I blocked off the end of the flared end that was inside the sediment basin just to give it kind of a pooling area. And that worked really well. So after that 6/10 rain event, it dissolved the polyacrylamide, and you've got clear water within the pipe with noticeable flocculation occurring in there. This is where the pipe discharged directly out into the small little plunge pool that was inside the sediment basin. And you can see again, we've got clear water and staining on the leaves and the stone where the flocculated sediment has settled out of suspension there. So just making sure I'm staying good on time. This was the outfall. And the one on the left was the outfall of the sediment basin on this job, but the second one is a different outfall. I just like the idea of this. So while neither one of these outfalls were treated with polyacrylamide, they certainly could have been. Rich was saying one of the caveats with polyacrylamide is that you want to make sure that you are treating and then capturing the treated water and soil and letting the flocculations settle out before you discharge from your job. So most of the time, treatment will occur either before the basin or in the basin so that the material can settle out in the basin and then clean water can discharge from the basin itself. If you have a treatment zone beyond the sediment or beyond the basin discharge point, then you are essentially still collecting flocculated material. So the image on the left shows a perfectly fine treatment zone. So you could treat within the stone area where there is excelsior material placed on it. So water comes out of the sediment basin, still comes into contact with polyacrylamide, and then you would essentially have a treatment area below that where flocculation, any of the flocculated material would fall out. So we had discharge from that one basin, and these are kind of on average overall turbidity values. So the flared end directly discharging from the skimmer pipe, or near the skimmer, I should say, 25.3 NTU, and then the silt fence beyond the outfall, so beyond that silt fence outlet, 8.88 NTU. So we're still getting treatment even beyond the initial outfall. By the time it actually leaves the site, the values of turbidity are still dropping out. This is a new site that was just installed with polyacrylamide end of last week. And so we'll see how things go. I just like to point out the layout. There's a lot of treatment zones here. There's wattles in the conveyance. Upslope, the diversion ditch has been lined. There's slope drain with stone collar around it. So rock inlet protection and a very nice stabilized basin that all of this is being discharged into. I did notice last week after everything was installed that none of the wattles had actually been stapled down. So that is a really important thing. They had them installed and they had the wooden stakes holding them in place, but especially when we're trying to slow water down in a diversion, the water has to have a barrier. And while we had those wattles installed in the ditch, If they're not properly installed or stapled down, the bottom of the wattle stapled down into the ground, the water certainly is just going to run right under them. So that was made aware to the contractor, and they had the guys fix them that afternoon. So glad that I saw it. Otherwise, treatment would have been bypassed. So that's a new site to keep an eye on. Okay. A couple of quick little studies that we did for this particular one was with the effervescent tablets, looking at silt sacks, a proprietary, but essentially a curb inlet protection bag, to see if we could treat within the bag itself. And so we ran a bunch of sediment laden water into the curb inlet bags, ran them over the effervescent tablets to see if we could get the effervescent tablets to dissolve and get treatment within the bags, and what kind of water we could get coming out the underneath side. And this was three different tests that were done each. So number one was the first test, number two, the second test, and number three, the third test. And these were, what's the word I'm looking for? The back-to-back tests. So the bags were not cleaned out. So the first test was run, and then we didn't do anything with bag except for add more muddy water and more polyacrylamide. And these were just overall turbidity reductions that we saw. So the first test, we saw turbidity reductions in the 40 to 50% range. And then the second and the third test, we saw significant reduction, upwards of 90 to 95% turbidity reduction. And what we noticed is that after the first test, we were getting more of that blinding, or the bags were becoming more filter, or more of a filtration device with the polyacrylamide in conjunction with it. So it worked really well. But like any BMP, the more sediment that you collect, the more often that they have to be replaced or maintained. So maintenance is also a really important factor to take into consideration when using polyacrylamide. And then I think this is lastly looking at another way to use gravitational flow. Rich talked about that with filter bags. Usually these are in a pumped setting with mechanical operations and mechanical pumping. We wanted to see if we could hook these up to a skimmer pipe outfall and just let gravity and the drawdown of the water run through the bags that were dosed with the effervescent tablets to see if we could get any reduction in turbidity just from gravity. And pretty preliminary, probably need to do this a couple of more times, but there were reductions in turbidity overall. So the bar on the left, the lighter shade green, is without polyacrylamide, and the darker shade green is with polyacrylamide. And these are all individual bags. So the first bag, we got 29% reduction. The second bag, 13 and 38 and 49 and 53, 49. So there was significant reduction actually in some of the treatments. I think what we found overall is that it's hard for polyacrylamide to treat just turbid water when there's not a lot of soil mixing in with it. So the polyacrylamide kind of likes that soil hole, if you will, the sand, silt, and the clay materials when it's treating it. And to treat just turbid water, it becomes a little more difficult. But nonetheless, with the geotextile bags, we were able to get pretty good reduction in turbidity. So that's another handy tool to have in your toolbox. So with that, I think that's all I had. And Rich, I think about 10 years ago, I had a different picture of this kid, my son, and now he's much larger and still catching fish. But I always like to have something fun at the end. So with that, I am done. And I guess if we have time, we can do some questions, Michelle.
Yeah, and you can just pass the ball back to me if you don't mind, Melanie. That'd be
Oh,
great.
gosh, I got to figure out how to do that again.
Oh, okay. All right, well,
Um,
we're gonna start from the top. Did you just click on the three little dots beside my
yeah.
my picture? Yeah.
Sorry, I'm trying to get that to pop back up, but I've got my three dots. Can I? No, I have to find your three dots.
Yeah.
It's not. It's to you.
It looks as if Rich has been answering a couple of the questions. So I'm just going to start at the beginning and we'll work our way down as many as possible. And then they will have their presentations. They will forward me their presentations. And so I will definitely post those on the website. They should be posted by Tuesday or Wednesday of next week. The video probably will be, the recording of this will probably be posted by the end of the week. So if you guys want to go back and revisit or that, then that definitely will be available on our website. So Allison wants to know, is there a risk to wildlife with passive dosing or with water quality if the passive dose comes into contact with just rainfall, not muddy water? The third part of the question, what happens with PAM after it adheres to the soil and settles? Does it need to be dredged to prevent moving downstream?
I can take a stab at that.
Hold on one second. I'm sorry, Rich or Michelle.
Mhm.
I passed the presenter back to Rich because yours wasn't coming up with the three dots. So Rich, if you want to share that with Michelle, I'm sorry that I had to go around that way. I just
That's okay. That's okay.
All right, I'm going to make Michelle presenter.
okay. Sorry about that.
No problem. So take a quick stab at that. There's really no toxicity concern with wildlife. I'm not sure if you're thinking about deer or if you're thinking about fish, but there's no toxicity issue really with the polyacrylamides, the anionics. And in fact, I put it in the chat, but the the flocks themselves are not toxic either. They're just like any other sediment. So we're emphasizing capturing them not because of any issue with the flocks, but just because it makes sense to try to keep all the sediment on site.
Okay.
There was another question I know about how often do you treat, and
Mm-hmm.
Melanie addressed that. She showed the empty suet cage, and that's essentially all you have to do is inspect the dosing sites, and if you don't see it, then you need to put some more out.
Okay.
That's a favorite question of contractors too. Is how often do I have to do this, and how much is it going to cost me, and can you give me a quote?
Okay.
And it really just depends on how often it rains and how much it rains and what kind of intensity that rainfall is.
And there was also part of that question about if you just had rainfall, um, you if you don't have enough rain to create flow, which would generally be turbid on muddy on a construction site, then you're not going to get any movement of polyacrylamide. So the cool thing actually is the rainfall activates it, starts to make it dissolve, and then when you start to get flow in the ditch, it's ready to start treatment.
Okay. All right. So I have another question. It says the chart appeared to suggest that in non-turbid water, the toxic threshold was lower than turbidity control level. Do you have to be careful to not apply it in non-turbid water? I'm not for sure, but did you already answer that, Rich?
Well, I did, but the bottom line is with most of these products, I hate to say this, but I muddied the water a little bit by talking about the cationic PAM because that's not really used very often in this application, and that's the only one you'd have to worry about. The others, even if they got into clear water, as you saw in some of the slides, that you're not going to see any toxicity. And of course, it's a waste to apply it to clear water anyway, so you want to make sure you're putting your application, your exposure zones where there's muddy water.
Gotcha. Okay, so and correct me if I'm wrong, I'm just trying to go through and make sure everybody's question is answered. If you apply the PAM to the inlet sequence, does it mix well in the basin water that bypass the inlet sequence?
Um, That's one of the principles, and you could see what Melanie was doing is she was making sure all the water that's going into the basin sees some treatment. And so you really don't want to see untreated water getting into the basin. It may get flocculated by residual PAM that's in the water from the treatment zones, but that's a real basic principle. You got to make sure all the water gets treated. Is that true, Melanie?
Yes, I was thinking in theory, if the polyacrylamide is dissolving and binding with the sediment as it's going into the basin, then that polyacrylamide is rendered useless, used at that point. So, like you said, unless there is a residual amount of polyacrylamide within the basin that hadn't been used, then the water getting around the treatment zone could then be treated in the basin. But really, and that's one of the hardest things, is to make sure that the water is all going through a treatment area. And I think that's why I use the slope drains as a treatment zone so often, because it's one of the more guaranteed treatment areas for water entering.
Okay, here's another question. What is the regulatory status of flocculants, required or not required? If not required, why not, since they seem to be quite effective?
Great question.
Yeah, well, I wish they were required, but yeah, they are not required. And there was another point made elsewhere about turbidity not being regulated. It actually is regulated, but not under the Sedimentation Pollution Control Act, which is what applies to construction sites for the most part. But when you get into streams, there are regulations about turbidity, and the way we actually discussed yesterday in the Sediment Commission meeting, one of the things you can think of is turbidity coming off a construction site is almost all sediment. And so it is actually sediment that's being controlled by flocculation.
Okay, all right, so we have another question. How does the effectiveness of the tablets on turbidity removal change the tablets dissolve? Have you looked at any changes in the effectiveness as the tablets become smaller?
No. I I have not looked at that. So the tablets themselves are 50 grams of material, and 5 grams of that tablet is polyacrylamide. They dissolve fairly quickly with water running over them. So what happens, and again, why I use them in the slope drains, is because that material is, once it's dissolved, it's washed all the way down the slope drains, and then is in the sediment basin where it can mix continuously with the rest of the sediment laden water until all of the polyacrylamide is used. So the polyacrylamide itself is dissolved off, if I'm saying that right, it's dissolved off of those tablets and then used to flocculate with the sediment. I don't know that as the tablet dissolves, the effectiveness of it becomes different based on, you know, less polyacrylamide within that tablet. I don't have
It would just have a little less surface area as it gets smaller, so
right,
it would
right,
dose a little bit less.
right.
Okay, all right,
And
so
I saw a question in there about a permit needed for flocculant use, and there is not a permit needed. The state does recognize um, uh, testing, or recognizes certain product out there based on toxicity testing. So they have a list of different materials or different products that have been approved based on toxicity requirements, but there is not a permit needed.
And somebody posted a link to that.
Oh, good.
Yeah.
Okay, good.
okay, another question. How is the flocculated sediment disposed, and are there regulations related to the sediment disposal?
The sediment is just like any other sediment, whether it's
Yep.
flocculated or not. You dispose of it on site usually.
Okay. Um, Jeff wants to know what is the brand of the effervescent tablets and where they can be purchased to test.
The brand is GeoScrub, and you can get those either through ACF Environmental, which I think now is Ferguson, or Green Resources, and those are local, or I should say North Carolina based.
Okay, let's see here. Andrew wants to know, have there been PAM concentration level testing at the outfall of the skimmers?
We did some testing long ago. It's hard to analyze because the polyacrylamide is a very large molecule. It's hard to do a typical analytical chemistry test for it. But you can test based on flocculation or some other things, and we found that the concentration would drop very quickly, from, let's say, in the tens to 20s, and in the inlet, and then it would drop at the outlet to the single digits.
Okay. I have another question for you, Rich. It says wildlife can be abundant, even on construction sites. Birds, deer, mice, turtles, salamanders, the list goes on. Are they at risk between the time the passive dosing happens when there's a rainfall event that pushes the PAM into the muddy water?
No, there shouldn't be any risk. Again, the main risk with polyacrylamide is that it gets very slick and sticky when it's wet, and they may get a little bit of, if they hang around on a wattle or something, they may get some material stuck to their hooves or their wings or something, I guess. I've never actually seen that happen in my experience. Maybe Melanie has,
No,
but
no, I haven't. I think I've seen
yeah. So,
more wildlife from the netting and the fabrics, but
yeah, yeah. And in the water, it should flocculate and be removed anyway. So there
mhm.
probably shouldn't be, for most construction sites, the water is going to be muddy to start with. So as Melanie indicated, that binds up the free acrylamide or polyacrylamide, and so there's no exposure really.
Okay. All right. Another question. And I know we're going a little bit past time, so I just want to make sure everybody is okay with this. Um, Another question is, are there thoughts on possible trapping nutrients with sediment in the flocks, and any thoughts on to temporary or permanent storage of dredged or mucked material, if so?
Well, if there are any nutrients associated with the flocculated material, they obviously would be removed. We typically deal with subsoils on construction sites, so there's really not much in the way of nutrient content in that type of soil. All that is in the topsoil, and that's usually stockpiled or trucked off and sold. So we've not done a lot of work with nutrient removal because we don't expect to see very much in the way of nutrients on construction sites. And then the other question was about the dredged material. I assume we're
Mhm.
talking about the material that was taken out of a sediment basin after it was flocculated. And as I said earlier, that you treat it just like any other sediment that you're removing.
Okay, I think we have a couple more questions. One of them asks, if you came up with the super turbid basin, would you ever apply powered PAM directly to the pond?
Yeah,
Uh, Go ahead, Melanie.
I, it's interesting. So in theory, that shouldn't work, right? Polyacrylamide really likes to have that mixing action. And so I think that I've seen it done several times actually. Some contractors will come in with water trucks and they will, or hydroseeders basically, and they'll mix polyacrylamide within the hydroseeder and turn it into more like of a solution. And they'll spray that out over the ponds, and you can get treatment. I've seen it. It will reduce the turbidity in a pond. I've also seen um, bigger ponds and somebody gets out there with a little John boat and a motor on the back of it, and they'll throw some polyacrylamide out and troll through it with their little motor and mix it up, and you can get treatment that way. I've seen that done too. I've seen homeowners associations put the polyacrylamide into the fountain in the middle of the pond, and you can get treatment that way. So I think that the only thing that I would say about that is anytime that you use polyacrylamide with any type of a motor, a mixer, a blender, whatever you're using, it can get slimy. So it's one of those that you have to be real careful with in the mixing, and that you don't have excessive amount of polyacrylamide and then you get this gumming, because that can mess up a paddle inside of a hydroseeder. It can mess up a fountain pump. It can, so you just have to be wary of that, and know that you need to probably do a little mixing or turn into some sort of a solution a little bit more before you encounter any kind of a engine.
And I think the question was about powder. Throwing powder out in a pond is probably, you might as well just take your wallet out and throw that out in the pond. It's probably not going to get any treatment. As Melanie just illustrated, you need mixing.
Yeah.
You can't just throw the powder out.
Okay. All right. So we have another question. Can you please share documentation / references that explain turbidity regulations in streams?
Well, Michelle, I think that's DEQ's job.
Yeah.
Oh, well, I was just like, okay, well, I will definitely get that one squared away, and get that sent to them. Okay, so here's another question. When PAM is added to the outside edge of a drop inlet protection, is there any concern about flux clogging, compromising the pipe system?
No, I've never had anything of that nature happen, nor or even concern of accumulation within the pipes. All I've ever seen is that when the polyacrylamide is added to the outside of the drop inlet, the sediment and then the polyacrylamide mix, and they are flushed through the pipe system. I don't think I've ever seen any even significant or very much settling within the pipe system. And again, all of these pipes are going into the sediment basins, so this is still during active construction, and it's not flowing off of the job at this point. But no, I've never seen anything like that.
Okay. One question is directed to you, Melanie. Have you used flock logs? Then one is do they last longer than tablets?
The flock logs are larger, so they do last longer, or they will treat more water, I should say, than the tablets. For me personally, I like the tablets. I think that they are easier to use, less sensitive to their environment. They're more of the effervescence allows them to dissolve as the water's running over them, and they don't dry out. They don't get covered because of the material that they're made out of. So I prefer the tablets.
Okay. All right. And then the very last question that we have is, are there any testing reducing dissolved metals with PAM?
I'm not aware of that. There is a company that claims to be able to pull metals out. I don't know anything about that, but yeah. So we've not done any testing along that line. I don't see that polyacrylamide itself might do that, but I don't have any data.
Okay. All right. So what I will do is, Javon, I think I'm pronouncing your name correctly. I would definitely make sure that I would send you the information regarding your question, and I'll make sure the documentation and references that we have that explain turbidity, I'll get that sent to you ASAP. So I will definitely contact the person and get that sent out to you. But I wanted to let everybody know. Well, first of all, let me just thank Rich and Melanie again for taking their time out of their busy schedules to assist us in this webinar. So your participation is greatly appreciated. So I definitely want to tell you thank you again. And also wanted to let everybody know that we will not have a webinar in the month of December. It's too close. The scheduled Wednesday is too close to Christmas. So we just decided not to do one for that month. And then also, if you are needing credit for attending this webinar, I have posted the link in the chat and I will post it here again. And if no one has any other questions, then I will let you guys go. And I want to thank you again for staying a little bit past our webinar allotted time. And again, thank everyone so much for your participation in these webinars. Rich and Melanie, did you guys have, oh, and they will be sending me the presentation. So I will be getting that uploaded to our website. So you will go to our training link, and then it should be up under WOW webinars. So. And if there's not anything else, then I will let you guys go and enjoy the rest of your day.
Thanks, Michelle.
Thank you so much for your participation. Bye-bye.
Bye.